Okay, so in this last video on the topic of the nervous impulse, I'm looking at the graph which represents nervous impulse. Now, those of you who find graphs and maths in general quite tricky, you don't necessarily have to include this graph, but I would like you to still kind of have a go at listening to what I'm explaining, because I'd like you to, at the very least, mention something called threshold potential. And I think the easiest way to understand it is have a go at kind of, showing what this graph is. So this graph shows you kind of a wave of action potential or nervous impulse. So on this side, you've got potential, and it's measured in units called millivolts. So it's written as little m and capital V, and this stands for millivolts. And on this side, you've got time, and this is measured in milliseconds, right? So little m, little s to represent millisecond. So here we're talking about really, really tiny amount of electricity, because that's what potential essentially is, right? So potential just shows you how strong, if you like, your electric current is, and the time, right? So for example, just to give you an idea, 1 second contains 1,000 milliseconds, and your action potential takes, on average, something like 4.5, 5 milliseconds, the whole thing, right? So we're talking about really, really kind of small amounts of time, and also small amounts of electricity. Just for comparison purposes, your AA standard battery contains 1.5 volts, and your electricity outlet, where you're plugging your computer into, or your lamp or your TV, that contains 230 volts, right? So here we're talking about thousands of a volt, and in your electricity outlet at home, we're talking about 230 volts. So that's why, if you try to stick your fingers in your socket, it's probably not a good idea, because your nervous system is just going to get completely overwhelmed. Okay, so when you have resting potential, so resting potential is in terms of numbers of how many millivolts this is minus 65 millivolts. So where you have this line just going along minus 65, so those sections are sections when your neuron is in resting potential. So I'm going to write that down. So that bit here at the beginning is resting potential, and then this bit right at the end, this is also resting. So resting potential right at the beginning, resting potential at the end. So this is minus 65, right? So at this point, if you remember, you've got a situation where plus is on the outside, minus on the inside, and somebody decided we're going to call it minus, right? And this number, kind of, how big that number is, it shows you the difference of the charges between outside and inside. So 0 would mean that there's no difference between number of ions on either side. So that's why it's 0. So here you've got resting potential, and here right at this point you can see that the graph is starting to climb. So why is it starting to climb? Because I've opened my sodium ion channels, and this resulted in flood of sodium ions onto the inside of the membrane, and that brought the reverse of the potential. So from minus 65, I've now gone to plus 40, right? And after that, I've opened my potassium channels, and then I've got the drop. So that whole section, that kind of peak, is my action potential. So this is action potential. Okay, so from this point to this point, right, the whole peak. So this is when sodium channels open, right, this side, and this is where potassium channels open at this side. Now, you also can see that here I've got a bit of a dip. Why is that? Because too much potassium actually goes onto the outside and kind of overshoots a little bit. So instead of going kind of neatly to resting potential, it goes a little bit beyond that. And we call that bit, that dip, hyper polarization. So it's like hyper being sort of over the top, right? So too much. So just that bit here. So maybe I'll point to it because I'm not going to fit the whole word here. So this bit is hyper polarization. Right, so hyperpolarization, just that deep. And then sodium and potassium pump is going to sort it all out and bring it all to resting potential. So that's where sodium and potassium pump start working, right, at this point, and it's all going back to kind of my resting potential and everything gets back to normal. So once I'm back to normal, then I'm ready to conduct the new action potential. So while you're here, sort of on this side somewhere, or on this side of the graph, you cannot actually generate the new action potential. So that's why there's like a limit to how fast you can do a certain action, like how fast you can do that, because you need to give your neurons time to actually sort out all your ions and put them on the right side of the membrane, okay? So obviously you can improve that with a bit of training, right, if you're a professional athlete, but still there is going to be a limit, you can't sort of reduce it to zero, you can't sort of do it, indefinitely fast. Right, so that's your graph for the nervous impulse, right? So another thing which I wanted to quickly talk to you about is something called threshold potential. I think that's important to understand what that means. Now, what that means is if you have a little impulse and your sodium channels open, but there are very few of them which open because the impulse is not very strong at all. And if that sort of peak only climbed to minus 55, then actually it's going to just simply die out and there is not going to be full-blown action potential, right? So even though kind of the dendrites, for example, right, are sensing that there is something going on, maybe a bit of your clothes is rubbing, against your skin, but because the impulse is very weak, it never actually generates the proper action potential and it never reaches your brain, for example. So you might be, wearing your home clothes at the moment or wearing your comfortable shoes and you're not really even thinking about it, right? Even though they're all kind of rubbing against your skin. And this is to do with threshold potential. And it's there in order to not overwhelm your brain with unnecessary little impulses, right? So you don't have to process huge amounts of information. So that's really quite a clever system of making sure that you're only paying attention to things which really matter. It's kind of strong impulses. Okay, and again, you can kind of adapt. Your body adapts to this threshold potential. So, for example, if you move into a house near a railway, so initially you can really hear every time a train goes past. So every bit of noise creates action potential. But then after a while, your body kind of starts to adapt. Your brain starts to adapt, and after a while, you kind of actually stop being able to hear it because your threshold has been lowered, and that noise does no longer generate, proper action potential, and you just became desensitized to it. So you're not aware of those noises. And the same is true for all sorts of, situations. Even kind of a certain emotional impact you might start be more and more immune to certain situations. You're all going to hospitals and you kind of start working there, and initially maybe a sight of blood or a sight of sort of wound might really distress you, but then after a while you just get used to it. Okay, so that's what threshold potential is. So that kind of completes my input on the topic of nervous impulse. So the next time I'm going to talk a little bit about the practical that you need to do for the last question in this assignment. Thank you very much. Bye-bye.